2020 exam, and let's go through some of that and start with the probability one because that's kind of an interesting one and brings in a lot of the terms that you'd have to use. And I don't know if 2 years ago is too early for them to repeat them, but they're fairly general terms, so they might. Um, so okay, so two events A and B are such that the probability of A is 3/4 and the probability of A and B is half. And then find this term here. So, and it's so you have to know what that means. So give your fraction. Okay, so the issue there is knowing what that is. So the probability of B slash A is the probability of B given that A has happened. Now, notice they say just two events, and they don't say whether those events are independent or dependent yet. So it doesn't matter at this point, but they will bring it in later, and it's kind of inevitable, you know that. So investigate if the events are independent later. So you just leave that aside for the moment, and we'll work in the general case, which you have to. So P probability of B slash A, given that A has happened. So find probability of B given that A has happened. Well, what's the formula there? Well, basically you want to bring in both of the things, obviously, that you do know. So P of A and B, so if you use that terminology, it'll help you remember, is the probability of A multiplied by the probability of B, but given that A has happened. And the reason you want that is the probability of A and B is, if you think it out and say it out in English, so the probability of A and B happening is the probability of A, and then you want the probability of B, but not just any probability of B. A has happened, so you want the probability that B is happening given that A has happened, because you want it to be the case for both. So let's just rearrange for what you want. So the probability of A slash B then is equal to the probability of A intersection B over the probability of A. So that's a half over 3/4. And just be careful about completing these. So multiply above and below by 4. So that's 2 over 3. Just be careful about that, about the fractions. You know, don't get the easy things wrong. So you're multiplying above and below by 4. So above, and you get 2 there, and multiplying below gives just 3. So you're just, because you've kind of got a fraction above and below, shouldn't disturb you. You're just multiplying whatever is above the line and multiplying below the line by 4. If you're multiplying by 4 over 4, it's multiplying by 1, so it doesn't change the number. So you get 2 over 3. So that's grand. So, and here we didn't have to determine whether they're dependent or independent. Now, so because we just say the probability of B that A has happened. Now, if they're independent events, then that will just be the same as probability of B, because if they're independent, then the probability that B happens will be totally independent of whether A has happened or not. So that's just something we'll look at later. So right, so now we have the probability of A, unit B. So A or B is equal to 11 over 12. Now, so probability of A or B is equal to the probability of A plus the probability of B. So remember, when we're talking about R's, we can add them, but we want to exclude the probability of B given that A has happened. So we want to leave that out because we don't want to double count. Sorry, the probability of B intersection A, of B and A. Okay, so then we get, do we know the probability of A? Okay, we're given the probability of that, so that's 11 over 12 is equal to, we know PA, which is, are we given it? Are we given it? We are. That's 3/4. Probability of B, we don't know. And minus the probability of the intersection, which is 1/2. Okay. So that leads us to say that the probability of B is equal to 11 over 12 minus 9 over 12 plus 6 over 12. Okay, so that's, what's that give us? 8 over 12, which is 2/3. So we get from that the probability of B is 2/3. Right, so now, so we're saying, given all that, investigate if A and B are independent. Well, they are independent if the probability of B happening is the same as the probability of B happening given that A has happened. And we know that's true. So the probability of B, so we get this and this, which are the same. So the probability of A / B is 2/3. Probability of B is 2/3. So probability of B is equal to the probability of B given that A has happened. So they are independent. And why is that? Because we've now proven that the probability of B happening doesn't matter. It has no relevance on whether on what has happened with A. And they're independent events. So that's like, say the probability that I go swimming is 1/3. You know, any one day it's 1 in 3. And the probability that I pass down a day is 1/10. Now those two events are totally independent. So the probability that I go swimming, given that I've eaten pasta, is still going to be 1/3 because it has no influence on the probability that I'm going to go swimming. So probability I go swimming is 1/3. Probability I go swimming, given that I've eaten pasta, is 1/3. They're totally independent. The fact that I've eaten pasta has no influence over whether I'm likely to go swimming. Probability I'm likely to go swimming is 1/3. Now, if the probability that it's raining is, say, 1/5, then the probability that I go swimming, given that it's raining, so let's say the probability that I go swimming is 1/3. Probability that I go swimming, given that it's raining, might be 1/10. So they're not equal. So that probability of raining has a big effect on the probability of going swimming. So they're dependent events. They're not independent. So, and because they're not the same, probability of swimming and the probability of swimming given it's raining, they're not independent. This is independent because the probability that B happens is totally unaffected by whether A has happened. All right. Okay. Yeah, this spinner thing is kind of a nice one. Let's have a look at it. And if you like, you could draw out a tree, and these trees are kind of useful. So you have a segment there, 3, you have 4 segments, 3 different numbers, you get a remainder when you add them. Your instinct, and it's good to have an instinct at start, it's not good to let that instinct influence you on the maths. My instinct looking at it is that it wouldn't be fair, because the remainder 3 is not going to be a kind of a linear factor, a linear operator really, so it's not going to affect them all equally. I'm guessing, I don't know, but it's good to have a gut for it, but you have to prove it anyway, so it doesn't really matter. But that's my instinct. It's good not to let that instinct, just purely let the maths work it out for you. All right, so we are told that you spin it twice and then you add them. So let's just draw those sectors again. So 1, 1, 3, 2. So you spin twice, and okay, so let's draw a tree. So spin 1 is equal to, okay, so you could do it a number of different ways. You could just do you could do a table showing all the different happenings. So 1, 1, 2, 3, and 1, 1, 2, 3, and add them here and stuff like that. But let's just draw a tree which is equally valid. So we'll just consider the 1 here once, and we'll assign a probability to it. So the probability of 1 happening is a half, because it's 2 quadrants. So it's 2 quarters, which is a half. Probability of 2 happening is a quarter, because that's just 1 quadrant. And the probability of 3 happening is a quarter, because it's just 1 quadrant. Similarly here, so given that has happened, you can throw a 1, 2, or 3, and it's the same kind of thing. So it's half, quarter, and a quarter for those trees, and similarly for those guys. Okay, so that's going to be 1, 2, 3, and 1, 2, 3, half, quarter, quarter, and so on. So you can then find the probability of each of them happening. So the probability of those guys happening is multiplying those two together, which you get a quarter. So the probability of that guy happening is a quarter. So that's 1, 1. Probability is a quarter. Probability of this guy happening is a half by a quarter, which is an eighth. That's an eighth also. This guy is a quarter, but that's an eighth. That is a quarter by a quarter, which is 16th. 16th. This guy is, so that's a half, so that's an eighth. A quarter by quarter, 16th. 16th. All right. Now, so what happens? You add them first. So let's add them up. Let's try and do it out logically. So that's 2, 3, 4, 3, 4, 5. What was this? 3. So it's a 4, 5, 6. And then you get the remainder and division by 3. So the remainder and division by, that's just the number, because so that's, there's no remainder. Dividing 3 by 3, 1, no remainder there. That is 1, 2, that is 1 remainder, remainder 2, and that divided by 3 gives no remainder. Okay, so let's see. So if the remainder is 0, Liam is king. So Liam has, okay, 3. So Liam wins there, there, and there. So he gets an 8th plus an 8th plus a 16th, which is 5/16. Sorika is on remainder 1. So she wins here, here, and here. So similarly, she's getting an 8th, an 8th, oh no, 16th, and an 8th. So she gets the same, actually, probability of winning, which is 5/16. And then Lee, if its remainder is 2, so where is he? So he's here, and he gets the probability quarter that that's going to happen. There, and a probability of 16th, and there, probability of 16th. So he gets, that's 4/16. That's 6/16. So it's only very slightly unfair. So Lee it's biased towards Lee, having a remainder 2, and only slightly, but still biased. So is it a fair game? Justify your calculation. So the conclusion is it's not fair. Let's just have a look at that. Yeah, 2/3, and this guy 2/3 is 2/3. Yeah. So let's have a look here. Lee has 6 chances to win. Yeah, 6/16, and the others have just 5 chances. Not a fair game. Okay, so that's an interesting probability question, and the independent dependent events is an important one. May or may not come up, but just good to know anyway. Exclusive events, just in case that came up. Exclusive events are one which, where P, that's an interesting one, where P given the probability of B given A has happened. If A and B are exclusive, then that's 0. So in other words, there's no commonality, so it's just they're exclusive. So one only happens if the other hasn't happened, and vice versa. So that's just a particular case. So an exclusive event would be if you pick something from a card, you pick a card from a deck, and the probability that it'll be a red will be, geez, what is it? It's half, isn't it? Yeah, it's half. The probability that it'll be a club is a quarter, yeah, because there's 4 suits, isn't it? Now, the probability that it's a red, given that it's a club, well, it can't be the case. Can't happen. You can't have a red club. A club is black, so it's 0. So they're mutually exclusive events. So they might throw that out this year. Okay, so probability, the group. This one is a fairly standard probability question. Nothing too tricky there. Probability that a car is Volkswagen. So basically, you're adding up all the fractional probabilities. So, so 0.3 by 0.7 plus 0.6 multiplied by 0.25 plus 0.1 multiplied by 0.09. So add those all up, and that should give you all those fractional probabilities add up to the full one. Okay, this one is fairly common now, these ones, and they're fairly standard ones. Regular driving tests, probability will pass as a quarter. They're all independent. Joe, along with 5 others, takes the test. Find the probability that Joe does the test with exactly 2 others. So that's a standard enough question. Comes up quite a bit, I would say. So, and I would say it's good to just write out that diagram of all the events. So it's how many lads are doing it? There's 6. 1, 2, 3, 4, 5, 6. So here's Joe, and his probability of getting it is quarter. Is everybody quarter? Yeah, is a quarter. And these lads, the 5 here, you're taking what you want, exactly 2 others. So it's 2 out of 5. 2 of 5. So the probability of that is equal to 5/2, binomial 5/2 of the probability of passing squared by 2, because there's 2 people passing. Probability of failing per 3, because there's 3 going to be failing. And then you have poor Joe out here with his probability of passing. So that's the probability that Joe passes with exactly 2 others, yeah. So, and then that 5, so you work out your binomial 5/2, you're passing, so the passing is a quarter, so that's a quarter squared, and the failing is then the difference between 1 and that quarter, so it's 3/4, and that's cubed and multiplied by your quarter of passing, and so you work that out. The 5/2 will be, yeah, you can put that into a calculator. It's grand. Okay, so that one is fairly straightforward. It's fairly common. Now, overall pass, so it's a different test center, so it's got, basically they're telling you it's got nothing to do with the previous question. And that's sort of something to be aware of. I suppose the opposite is something to be aware of more often. That as you progress through a question, sometimes they're being nice to you and they're allowing you to use a previous part of a question. So you don't have to reinvent the wheel and work from scratch. So just be aware of that sometimes. And sometimes you have to be aware of it because you have to use the relevant info from the previous one. If they're telling you here, they're being nice to you and explicitly telling you that it's a different center, so we're starting from scratch, right? Okay, so in a particular day, okay, number of people, probability that 2 people or less than 2 people pass the test can be written in the form. So they're being kind of kind to you there, and they're giving you a clue that it's not just straightforward. Probability that 2 people or less than 2 people. So I suppose the trap that people might fall into there is just finding the probability that 2 people will get it. But that's not the case. You need to find the probability. So the probability of 2 or less than 2 will be equal to the probability that 2 get it, plus the probability that 1 gets it, plus the probability that nobody at all gets it. Okay, so it's then work out these guys. So, and it's n people doing it. Okay, so n people are doing it, so it'll be n2 probability of passing. Well, nicely they've said the probability of pass rate is a half, which means the probability of failure is a half as well. So that'll make things easier. So it'll be a half to, so 2 people are passing this, and I just have to be careful. So, so that is 2, yeah, a half squared, and then the rest of them fail, and their probability is a half as well, but the number of people failing then is n minus 2. So the total is n, 2 people passing, yeah. And then plus, you have to add the other lads. So n1, a half, and in this case, that's just the power of 1, and the number, and a half are, and the number here is n minus 1 now. So it's basically all the rest of them are failing it. And then the last one, it's n0, a half people are passing to the power of 0, and basically it's just everybody failing. So it's half the power of n. So, yeah, so this guy, the main one to remember here is that n0 is 1. So that one is 1. And that's, I think, in the log tables, but it's just something, I think you can remember that anyway. So just putting in the formula, so that's equal to factorial n over factorial 2 by n minus 2 factorial. And then it's a half to the power of n plus factorial n over factorial 1, which is just going to go to 1, and then n minus 1 factorial. And then a half to the power of n plus, this guy is just going to be 1. That's going to be 1 as well, anything to the power of 0, and then it's a half to the power of n. Okay, so now we have nice common factors here that we're going to take out. So we can take out 1 over 2 to the power of n, which would be, yeah, 1 over 2 to the power of n, which is grand. We take that out. Now, always keep an eye on the answer, and it's 2 to the power of n plus 1 underneath, and I think that's just because we have the 2 under here. So let's take out 1 over 2 to the power of n plus 1. So that's basically, we're taking out this 2 to the power of n underneath the line, and we're also taking out another 2 to account for that. So it'll just, so that'll be, it'll double these guys basically. So we'll just have to be aware of that. Now, so factorial n, so now that other 2 has been taken out as well. So factorial n over factorial n minus 2. So that is, let's go n by n minus 1 by factorial n minus 2 over factorial n minus 2. All right. So as you can see, with all these things, we get nice cancellation there. Okay. Plus factorial n. So it's plus n by n minus 1 factorial over n minus 1 factorial. As you can see, nice cancellation there as well, and we're just left with n on that bit. Now, we do have to multiply that by 2, because we're taking out kind of 2. We don't have to do it that way. You could just take out 1 over 2 to the power of n, but it's just, it will just kind of leave a fraction. So it's good not to leave the fraction, so take out the extra 2. This one, what have we got? Nothing. We just have a 1 because we're oh no, we have the 2. Just have to be careful. God. Okay, so now it's starting to look like the answer. So the answer there, we've 2 to the power of n plus 1 underneath, and that's what we have, which is great. Always keep an eye on that. So, and then we're left with n squared plus n squared minus n plus 2n plus 2. Okay, so it's equal to n squared plus n plus 2 over 2 to the power of n plus 2. So our answer, and it's important to write it down specifically, is that a then will be equal to 1, the coefficients, b will be equal to coefficient of that, which is 1, and c will be equal to the coefficient of the constant, which is 2. So 1, 1, 2, and let's hope that's what they got as well. Let's see. Where is it? Yeah, 1, 1, 2, yeah. So adding them both together, and you get that. Okay, so there are your coefficients. That's an interesting probability question and something to just be aware of and watch out for. Where is now let's have a look at, there was an interesting one here. Yeah, this is a nice one here. So it's dealing with median, range, interquartile range and stuff like that. A lot of that is from the junior cert, but it's kind of good to remember it. So, and it's a nice, interesting question. So basically it's like a little puzzle from A to H. Okay, so how do we do it? So we're going to do